This is a key to the worksheet on solving absolute value inequalities. There are 4 problems in this worksheet. You did need to state the solution in interval notation. Notice, though, that some of the absolute value inequalities are less than and some are greater than. And the way we solve each of those is different. So let's look at the first one. So in the first one, when you have an absolute value inequality, one of the first things you do is to make sure that the absolute value expression, the absolute value bars, are by themselves. All right, is on one side of the inequality statement. So notice that this is what I have here. So I have the absolute value of 3x minus 5. The next thing you want to do is make sure that the coefficient in front of the absolute value bar is a 1, and it is here. All right, so once it looks like this, with an absolute value less than only, you're going to write as a compound statement. All right. Now, do not confuse an absolute value inequality with a linear inequality. This right here is not this. All right. So solving a linear inequality is different than solving an absolute value inequality. Okay. Those are not the same. This is absolute value. This is linear. Okay. When solving a linear, you would add 5 to both sides, right? And then you get 3x is less than, in this case, 8 plus 5 is, what's that, 13. Then divide both sides by 3, and so your solutions would be any number less than 13 thirds. But that's not the case here, all right? So you got to be careful. Don't confuse the two. All right, so when solving an absolute value less than inequality, we're going to change it to a compound statement, and so you're going to write it like this. All right, so listen carefully. So first of all, think like this. All right, so you're going to think 3x minus 5 is less than 8, and at the same time, 3x minus 5 is greater than negative 8. All right, so notice the less than. So basically what you did was you rewrote this without the absolute value bars, and you made an and statement, and then you said, well, 3x minus 5 then must be greater than. So this is less than, this is greater than, this is positive 8, this is negative 8. But what we did, though, was we wrote it differently. So we wrote this as a compound statement, which looked like this. 3x minus 5 is less than 8, right? So that right here is what you see here. And at the same time, 3x minus 5 must be greater than a negative 8. So that's why you saw this. So that's how we wrote it. So basically all you do when you see an absolute value less than is you take that expression that's on the inside of the absolute value bars, and you're going to say it's going to be less than this number here, and at the same time it's going to be greater than the opposite of that number. All right, opposite, look, same, opposite, same, opposite. And this inequality symbol is in that same direction, less than, less than. But when you read this, one way to read this is to say 3x minus 5 is less than 8, and it also must be greater than a negative 8. Okay? All right, and then the next thing you do is just get the variable x by itself in the middle, and you will find the solutions to the original problem. So you're trying to find any real number such that when you take the absolute value of this expression, it's going to be less than 8. And so to solve this, we're gonna write equivalent statements so that we get x by itself. Once we get x by itself in the middle, you've found all real numbers that will make this true. All right, so let's first of all add 5 to both sides. And so when add 5 to both sides, you get negative 8 plus 5, which is a negative 3, is less than 3x, this is 0, which is less than 8 plus 5 is 13. All right, then you're going to get x by itself, so you're going to then divide both sides by 3, just like this. And so negative 3 divided by 3 is a negative 1. It's less than, and this is just x, it's less than, and then 13 thirds. All right, now remember 13 thirds, if you want to, you can write this as a mixed number. So 3 into 13 is 4. 4 times 3 is 12 with a remainder of 1. So this is 4 and 1/3. So you can write it. You can write it as this, 4 and 1/3. Okay. All right. Now you found your solution. So any real number that's in this interval, either this one or this one, is a solution to the original problem. All right. And you can always check. So let's just check one of them just to show you. So for example, if I check, if you pick a number in here, let's use this since that's a mixed number. So let's say 2. 2's in here, right? So let's see why 2 works. So I'm just going to show you why 2 works. Why 2 is a solution. So why is x equal to a solution? So if I substitute 2 in here, in the original inequality, always go back to the original, you're going to get the absolute value of 3 times 2 minus 5, and I want to see if that's going to be less than 8, right? Well, 3 times 2 is 6, and 6 minus 5 is 1. So the absolute value of 1 is at less than 8. Well, the absolute value of 1 is 1, and 1 is indeed less than 8. And then if you pick a number that's not a solution, so let's say 7. So 7 is not in here. So let's see why 7 is not a solution. So why is x equals 7 not a solution? All right. Well, the reason it's not a solution, for one thing, you see it's not in that interval, right? The other thing is that when you substitute x equals 7 into this inequality statement, it's not going to be a true statement. So watch. The absolute value of 3 times 7 minus 5, and you want to see that's less than 8. Well, 3 times 7 is 21, right? And then 21 minus 5, what's that? 16. And the absolute value of 16 is at less than 8. Well, absolute value of 16 is 16, and 16 is not less than 8. So that's why it's not a solution. Okay? All right. So, but you want to write your answer in interval notation. So the interval notation, you're going to say, since there's no equal sign, you're going to say parentheses -1, 2, 13 thirds with a parentheses. Or you could have used 4 and 1/3. Does not matter. All right? But remember, with absolute value less than, you're going to change it to a compound statement right here. You're going to change it to this, and you're going to get x by itself in the middle, and there's your solutions. All right? Okay, so that's the process you're going to use when solving an absolute value less than. Okay, let's look at number 2. So number 2, we have this in number 2. So number 2, we have the absolute value of 5x plus 1 minus 2 is greater than or equal to 3. All right, so first of all, we need to make sure we get that absolute value expression by itself. So I've got to get rid of this subtract 2 right here. So the opposite of subtracting 2 is to add 2. All right, and so when I do that, I get 5x, the absolute value of 5x plus 1 is greater than or equal to 5. All right, now be careful. This is an absolute value greater than. This was an absolute value less than. All right, so less than. So that's that compound statement. That's that and statement right here. The 3x minus 5 must be less than 8, and at the same time, it must be greater than -8. With a greater than, and so when you think greater than, you got to think of the word or. Okay, or. So you're going to write an or statement here. You're going to change this to an or statement. So that or statement is we're going to actually write 2 statements. You cannot, I repeat, you cannot write this as a compound statement. If you do, it's mathematically incorrect. Do not do the mistake and write this as a compound statement. You must write this as an or statement. You saw that when we talked about this in those lessons before you actually did this worksheet. Okay, so you can write this as an or statement. Here's how you're going to do this. First of all, you're going to write this without the absolute value bars. So the solutions to this, so here's your solving process right here. You're going to say 5x plus 1 must be greater than or equal to 5, or 5x plus 1, 5x plus 1, same thing here. See 5x plus 1, 5x plus 1. And remember when we talked about that and statement, this was less than, this became greater than, 8, -8, same thing. So now you're going to say 5x plus 1 must be greater than or equal to 5, or 5x plus 1 must be less than or equal to the opposite of 5, which is a -5. All right, but it's an or statement, okay? So notice greater than equal to, you change the sign, okay? And same, and then opposite. And then now you solve each of those statements. So with an or, with a greater than, you must write an or statement. So when thinking about greater, just here's the spelling of greater, right? But kind of emphasize the greater, the greater part, the er part as or, greater. All right, so you just think of greater just think of the last two, instead of saying ER, say OR, and then you know it's going to be an OR statement. Okay, so now let's solve each for x. So each linear inequality. So I went from an absolute value inequality to two linear inequalities. So let's solve each one. So I'm going to subtract one from both sides. So I get 5x is greater than or equal to 4. Divide both sides by 5. I get x is greater than or equal to 4/5. Okay? So be careful. Remember, I'm trying to find the solutions to the original right here. So the solutions to this is the same as the solutions to this because those are equivalent. What I found, though, x is greater than or equal to 4 are the solutions to this linear inequality. So you got to be careful. That is the solution to this. This may not be the solutions to this. Okay, you got to look at this as well. Okay, you got to remember this is an OR statement. All right, so you have to be careful. Okay, over here, let's solve for x. I subtract 1 from both sides. I get 5x is less than or equal to a negative 6. Divide both sides by 5. I get x to be less than or equal to negative 6/5. Okay? All right, so what I found here is the solution to this linear inequality. All right, but I'm trying to find the solution to the original, right? The one that's the absolute value. Okay. Now the direction set to write this as a interval notation. Before we do that, let's look at the graph. When you have an OR statement, look at the graph for a moment. So x is great. So on the graph, make sure you put the numbers in the right order. So negative 6/5 is going to go here, and then 4/5 here, right? So the solutions to this inequality, is this. So it's going to be, this one here is this, I'm sorry, greater than 4/5, and for this one, that's this one. All right. So this is an OR statement. All right. What I found here is that those two intervals are pointing in different directions, so they don't overlap, right? They don't overlap at all. All right. They're distinct. So therefore, this is actually going to be a solution to the original. All right. So the solutions here is a solution to the original. So in interval notation, you're going to say, you read a graph from left to right. So you can say negative infinity to negative 6/5 with a bracket, negative infinity to negative 6/5 with a bracket, union, and then bracket 4/5 to infinity. So that's how you write your solution to interval notation. Okay? All right. For the most part, you're going to notice, you're going to recognize for the most part, that's not always true because there are special cases, that when you have an OR statement, for the most part, you will see the solution being two intervals like this. You're going to see it being two intervals like this. When you, for the most part, not always true, because there are some special cases, but when you solve an absolute value less than a compound statement, you're going to see the solution being one interval like this. Okay? There are some special cases where you could have no solution, but we haven't talked about that yet. So be careful. But for us at this moment in time, when you have an absolute value less than, your solution is going to be that one interval. It's going to be one interval. When you have an OR statement, notice that those two inequality statements here that I'm pointing to, that's this. They are unique. They don't overlap at all. So you end up with two intervals. Okay. All right. So that's number 2. So let's go to number 3. So number 3, we have this. We have 3 times the absolute value of 2x minus 4 is less than or equal to 12. All right. So first of all, remember we have to get that absolute value bars by itself. So let's go ahead and get rid of this coefficient 3. So we're now multiplying by 3, right? So let me go ahead and rewrite this over. I'm multiplying by 3. First thing you want to do is to divide by 3. Divide both sides by 3. And when I do that, 3 divided by 3 is 1. So 1 times the absolute value of 2x minus 4 is the absolute value of 2x minus 4. It's less than or equal to, and then 12 divided by 3 is 4. Now see, this is an absolute value less than. So less than, that's that compound statement. And remember, when we have that less than, for us, we're getting our solution will be that one interval. Okay, it's going to be one interval with the less than. All right, so let's go ahead and write this as a compound statement. So the first thing you're going to do is rewrite what you see without the absolute value bars. So 2x minus 4 is less than or equal to 4, right? At the same time, it has to be greater than or equal to a negative 4. You take the opposite. Okay, the opposite. So same, opposite, right? And then notice the inequalities are pointing in the same direction. Okay, so absolute value less than, compound statement. Absolute value greater than, an or statement. See how different it looks? Greater than, or. Okay, we end up with two intervals. See that? Absolute value less than, a compound statement. That's that and statement. So 2x minus 4 is less than or equal to 4. And at the same time, notice I said and at the same time is greater than or equal to negative 4. So when you do that one, you'll get one interval for us. Okay, there are situations where you could get no solution, but we haven't talked about those special cases, so there'll be no solution. But we haven't done that. For us right now, it's what you see. Okay, so let's go ahead and get x in the middle. So once I obtain x in the middle, I will have found the solutions to the original inequality. Okay, all right. So I'm going to add 4 to both sides. And so when I add 4 to both sides, and negative 4 plus 4 is 0, right? It's less than or equal to, this is 0 here, 2x is less than or equal to 8, correct? And then I'm going to divide both sides by 2. 0 divided by 2 is 0. Is less than or equal to, 2 divided by 2 is 1. 1 times x is x. It's less than or equal to, and 8 divided by 2 is 4. So all the real numbers between 0 and 4, including 0 and including 4 because of the equal sign, is going to be a solution to the original inequality. Okay? And you can check, if you want to check that one, watch, I'll show you. If you want to check that one, let's just go ahead and use this. If you want to check this one, let's just think. So let's pick a number that's in here. So let's say 2, right? X equal 2 is in here. So that should be a solution to the original. So let's just check x equal 2. So in place of x, I'm going to substitute 2. So I get 3 times 2 times 2 minus 4. And I want to see that's going to be less than or equal to 12, right? Well, 2 times 2 is 4, correct? 4 minus 4 is 0. So I get 3 times the absolute value of 0. And I want to see if that's going to be less than or equal to 12. Well, the absolute value of 0 is 0. And then 3 times 0 is 0. So is 0 less than or equal to 12? And the answer is yes. All right. So any number in here, any real number in here, could be decimals, fractions, rational numbers, irrational numbers, as long as it's in here, will be a solution to the original inequality. So in interval notation, your answer is going to be bracket 0 to 4 bracket. Okay. But there's the work. You have to show this work. All right. Okay, and then finally number 4. So let's look at number 4. In number 4, we have the absolute value of 7x plus 2 is greater than 9. So notice it's a greater than, all right? So when you think, and by the way, the absolute value bars are by themselves. There's no number here. So when you have greater than, think that or statement. So you have to write two separate inequality statements, okay? So the first thing you're going to say is this without the absolute value bars. So I'm going to have 7x plus 2 is greater than 9. So I'm trying to find the solutions, any real number for x that will make this left side greater than 9. And there's no way you can look at this, so you got to come up with a solution process. All right, and so that's our process. You're going to write as an or statement to get to the point where you can actually determine what real numbers will work. Okay, so first thing you do is write the inequality. Write one of the. There are going to be two inequalities. One will look like this without the absolute value bars. The other one is where you're going to change this side here, right here. So you're going to say 7x plus 2. So the greater than becomes less than. 9 becomes negative 9. So that's all you do. Okay, and so now notice I wrote this absolute value greater than inequality into two linear inequalities. All right, it's very important, though, that you see this is greater than, this is less than. This is 9, this is negative 9. Okay? All right, So they have to be opposites. 9, -9 are opposites. Greater than, less than. Okay, so let's solve each inequality, linear inequality. So I get subtract 2 from both sides. So I get 7x is greater than, and then this is 7. So if I divide both sides by 7, I get x is greater than 1. So far, if I put this on the number line, and for the R statement, I always tend to put it on the number line to help me to make sure that those solutions will be the solutions to the original. So x is greater than 1. So I'm going to put that here. Oh, and let's go ahead and solve for x, this one here, because I need to make sure that I put the smaller number here and the larger number here. So let's just do that first. Subtract 2 from both sides. I get 7x is less than -11, right? And then divide both sides by 7. I get here x to be less than -11 sevenths. So I'm going to put this as -11 sevenths right here. So that's going to be this side. And then greater than 1 is going to be this. And so those are two separate inequalities. So both of those will be solutions to this one. All right, they don't overlap at all. So in our cases, when we do these, you are going to see those two separate solutions, those two separate intervals rather, and those two will actually be solutions to the original. Okay, so our interval notation. And some students also like to graph it because when they put this in interval notation, they can read it from left to right. So from left to right, I go from -infinity. Remember, this is open circle, right? Because there's no equal sign. So I go from -infinity to -11 sevenths, -infinity to -11 sevenths with parentheses union, and then parentheses 1 to infinity. Okay? All right, so that is how you're going to deal with absolute value inequalities. So remember, greater than, you're going to change to an R statement, and then less than, you're going to change to a compound statement. Okay, and that's it. So that is the key to the worksheet and absolute value inequalities.